Okay, so I'm going to step you through how to use this online graphing calculator to do the problem in the homework that asks you to plot up your force and displacement data to calculate the spring constant. So I've made up some fake data here. So we will call this data in column A to be the force and the data in column B to be the displacement. This isn't obviously what you will have, but I just wanted some data to be in there. And of course, you don't need to make an account or do anything fancy here. You can see that I haven't done any of that stuff either. So once you've entered the data that you have calculated from the PhET, you're going to trace your data. So over here, for me, trace is just automatically opened. So a trace is going to plot this data as a scatter plot. So I'm going to click on the trace, and this thing comes up. It has defaulted to a scatter plot, and that's what I want. My x data, which will be what is plotted on the x-axis, I'm going to choose to be the displacement data, and my y data will be the force data. So I'm going to go down here just so I remember what I plotted. This is displacement meters, and this is force. I'm just clicking on the title, and then it lets me change what it is. So this is the weight or gravity force in newtons. Okay, so now that we have this figured out, this data is plotted up, and you can see that it falls onto a pretty straight line, and that should also be true of your data. You should have a pretty straight line for your data, maybe not as perfectly straight looking as this is right now, but I guess we'll see how perfect it is when I get a best fit line on there. So before we do that, we need to think about what type of thing we should fit to this data. So let me tell you what I mean by that. Right? So we are using Hooke's law, which says that the spring force is minus k times the displacement from equilibrium. And we've calculated not the spring force, but the weight. But if you think about this spring right here with a mass hanging from it, right at this dot, let's draw a force diagram. There is weight, which points down, and there is also a spring force that points in the opposite direction. These two forces have to be equal and opposite, or this thing would never stay still. And we've seen in the lab that it can stay still. So when this spring is at its equilibrium position, these two are equal and opposite from each other. So rather than having the spring force here, I'll say the force of gravity equals minus k delta x. And the force of gravity, well, that's just mg. So I have mg equals minus kx. And this is something that we've used in the lab to say solve for the mystery mass. That's something that we've done and stuff like that. We're not going to actually use that now. That was maybe a step too far, but just to kind of show you some things that you might have missed when you were doing the lab. All right, so this is the relationship that determines how force and displacement are related to the spring force here. Okay, so we have that this is a proportional relationship. And by that I mean a proportional fit says that what is plotted on the y-axis equals the slope m times what's plotted on the x-axis. All right, so if we plot the weight on the y-axis and we plot the displacement on the x-axis, as we just did, then the slope of a line that includes the y and the x data should be k. And that's what we have there. Oh, and I actually just noticed I have a mistake here. Right, this negative goes away because the spring force and the gravity force point in opposite directions. So what we should say actually is that the spring force is negative of the weight force. So I have a negative on both sides. I'll just turn those both into positives. So that should be a positive there as well. Okay, so this is what we want, is we want a proportional fit to a plot of force of gravity versus the displacement. So now let's go back to the Plotly window and find out what we need to do. So we would like to analyze this data, so we'll click on Analyze, and now we'll move down to Curve Fitting. And now I want to add a fit, so I'm going to put on the plus fit here. And now we'll select a trace. We only have one trace, so we'll just select the one that is already up there. And now we have basic and advanced tabs. And so the family function is linear. I'm going to drop down there because we actually don't want a linear fit, right? Linear is not a proportional fit because there is the option for having a non-zero y-intercept here, right? Hooke's law is not force is kx plus b. Hooke's law is just that the force equals k times x. So we want to force b to be 0, and that's not a linear fit, but proportional. So we go here and we look, and there's linear, and actually nowhere on this list is proportional, one of the options. So we can't use basic, we need to go over to advanced and just define our own function, which is fortunately very easy. So our custom function has been set to that linear fit, mx plus b. Let's just get rid of b, get rid of the possibility for a y-intercept. Okay. And let's click on Run. All right, I didn't like that we clicked on Run without giving a guess for what we think the slope might be. So I'm just going to put in a number here. It doesn't matter what number it is, it just needs a number to start with. I don't know why. And there we go. So I put in 10, but now m has changed to not be 10. M here is the slope of the line. Okay, so what I want, what would be awesome if you submitted is just to take a screenshot of this whole thing and paste it into your Word doc or whatever it is that you're using to submit, and that can just be your answer to this question. But right here, this is the slope of the line. So it is, I'm going to write it on my sheet of paper and then I'll move over there. So I have k is 0.81033372. Okay, so let's go over to this thing here, right? So that's what I found k to be. The units of k, right? K is a Newton divided by a meter, which we can see from the formula, or sorry, Newton per meter. It would be, we're not going to have uncertainty on this number. It's possible to calculate, but we're just not going to. But I would like to think about sig figs. So how many sig figs did you have in the force and how many sig figs did you have in the displacement? And that will inform how many digits you should report here. You almost certainly don't need this many digits, but I will leave that up to you to decide. Okay, and that is all I have for this video.